I'm one of your main speakers for today. My name is Anish Tilak. I'm a manager in the Carbon-Free Buildings program at RMI on our Embodied Carbon Initiative. And I'm joined by Connor Usry, who is another author of our report. And we're excited to present our findings to you. So why are we here today and why are we focused on the US government? The US government is the largest consumer in the world and has a lot of purchasing power. And by focusing on embodied carbon and reducing embodied carbon in building projects, the federal government has a huge role to play in supporting the development of a clean domestic industrial sector, and also using that purchasing power to seed market transformation, seeding the next generation of innovative low carbon materials. Our top line finding from our analysis is that by 2050, the federal government can achieve not just zero embodied carbon from building projects, but actually we can store carbon in the federal government's real estate portfolio. So that's a really exciting opportunity and unique in embodied carbon. So our agenda for today is that we're providing a broad overview and some context of what we did. And then we'll dive into some details about Buy Clean, which many of you have likely heard about. That's an increasingly common policy to address embodied carbon in the built environment. So we drill into some details about Buy Clean and what's happening at the federal level under the Biden administration. And then we'll touch on some of the strategies to address embodied carbon beyond Buy Clean. So looking at buildings more holistically and thinking about other strategies beyond focusing on specific material sectors. Just some housekeeping on Q&A. We encourage you to use the Q&A function to ask questions along the way. We'll respond immediately if it's a simple clarifying question, but we're leaving 15 minutes at the end for more detailed questions. So we'll try to get everything answered and get a good discussion going by the end of this. And we're also going to be recording this presentation so we can share it in the future. So just kind of a disclaimer on that piece. So while we're focused our analysis in this specific report on the US federal government's portfolio, we believe that the information in the report is really a comprehensive framework for addressing embodied carbon that policymakers at the local and state level, as well as private real estate portfolio owners, can also use. So this isn't so niche that we're focused just on one portfolio. This is really something that anyone should be able to pick up and deploy in their real estate work. And with that, I'll hand it off to Connor to just give us some context and get into Buy Clean.
Cool, thanks, Anish. So I guess before we jump into some of the calculations, I just wanted to give a quick refresher on what embodied carbon actually is for those of you who are a little less familiar. So embodied carbon is the carbon that is in construction associated with the lifetime of a building. So that ranges from the raw material extraction to the emissions during the transportation of materials, all the way to the end of life when you are dealing with the deconstruction, disposal, or recycling of materials at the end. So essentially everything outside of the operational carbon that's used. Next slide. So embodied carbon is really significant. The emissions from concrete and steel industries alone account for about 21% of total global emissions. And most of the products from these industries are being used in the built environment. So as a result, policies that target these emissions, such as building code language, procurement policies, are really effective in addressing and reducing some of these emissions. But we should be looking at this not only in terms of having really large greenhouse gas emissions reduction potential, but also this is an opportunity to reap a lot of different co-benefits. So that is anything from improving air quality and pollution levels in areas near industrial manufacturing, all the way to supporting regional and local manufacturing and innovation. And it's also really cost effective. RMI has produced a couple of reports of late that have shown that emissions from materials that we purchase for construction can be reduced by up to 46% with little to no added cost. Next slide, please. So, in order to actually get the federal government to reduce its embodied carbon emissions, our team has developed a roadmap that's based on 4 primary strategies. The first, and the one that the government is really actively working on already, is developing a robust buy clean procurement program, which sets emission standards and targets for building materials, especially the large and important ones that we'll talk about here in a bit. The second is investing in the future of building materials by setting procurement policies that encourage the use of deeply decarbonized building materials for federal projects that's outside of the atypical ones. The third is setting whole project embodied carbon performance standards to look beyond individual building materials and consider the project as a whole. And then lastly is setting a portfolio planning framework that'll capture the significance of embodied carbon throughout the various stages of the life of a building. Next slide. So our roadmap focused on 2 core ways of approaching embodied carbon evaluation and reduction. We'll dive into those specifics throughout the next hour, but I just wanted to kind of highlight the estimated impacts up front. So the first impact projection is from widespread implementation of buy clean targets that we're going to recommend. And then the second impact projection is that we see even greater potential for reduction is by emphasizing performance standards through whole project lifecycle assessments rather than just focusing on individual materials. All of this is going to be in relation to projected emissions that we calculated that the federal government will emit if it operates its portfolio in the same way that it already has been. Next slide. So first, we'll take a look at that buy clean approach that I mentioned in the first part of the last slide. So buy clean as a whole, what is it? Buy clean is a policy that is being used or evaluated at least in a number of different states across the US already. Essentially, what it does is it sets procurement standards for common carbon intensive building materials. And since the government, as Anish mentioned before, has enormous purchasing power, its procurement stipulations can help drive the market towards lower embodied carbon. It's focused predominantly on the upfront greenhouse gas emissions of building materials from the extraction and the manufacturing, but it still yields results throughout the lifespan of a project. And it targets really specific carbon intensive sectors, such as concrete, steel, insulation, asphalt, and glass. Next slide. So what does this mean for the federal government in particular? Well, the federal government is the largest consumer in the world. It spends somewhere in the range of $650 billion on products and services every year, and it has a portfolio of about 2.8 billion square feet. So a push to procure lower embodied carbon materials will actually help shift the US market as a whole towards those lower embodied carbon materials. Last fall, in 2021, the Biden administration issued an executive order making buy clean a priority for the federal government, which was a huge step. And what that stated is that the federal government is going to focus on developing pilots for low embodied carbon procurement in order to push those lower emission standards for key materials. Those key materials, I'll cover in a second. But this fall, after assembling a task force across various federal agencies, they stated that those materials were going to be concrete, steel, asphalt, and flat glass. And those are going to be the priority projects or priority materials for buy clean. In addition to those pilots, the executive order stated that they were going to focus on collecting and publicly disclosing environmental performance data. And they're also going to be streamlining emissions reporting as a whole. Next slide. So the priority materials that Buy Clean announced came on the heels of the historic Inflation Reduction Act, or IRA, this fall. And among a lot of other things, it's going to advance the market for low embodied carbon materials in buildings through a few different levers. The first is a $250 million program that'll help building manufacturers develop environmental product declarations, or EPDs. These are something similar to nutrition labels for materials to help people understand how much carbon is being used in the production and transportation and use of them. $100 million is going to go towards supporting the creation of a national eco label for low carbon materials. That's similar to the successful Energy Star program that you see stamped on the back of washing machines and dryers and microwaves these days. And then in addition to that, there's going to be $2 billion that are put towards enabling the GSA to buy and to use low embodied carbon materials for construction projects. Next slide. So shifting back to RMI's efforts to try and help the federal government achieve some of their goals. A federal buy clean pathway, like the one that we actually proposed in our report, is going to set the US government on the right path towards reducing emissions over time. The analysis sought to establish targets for the priority materials that are used in construction by the federal government. In order to do that, we first needed to determine which materials these actually were. So according to our analysis, these listed here on the slide are the primary emitters for federal construction. Since concrete and steel are the top contributors to embodied carbon from typical federal construction by a pretty large margin, as you can see, we did a deep dive analysis into these two, and then we considered the others with a little bit more of a broad approach. Next slide. So a huge part of buy clean is being able to set benchmarks and reasonable emissions expectations for different materials. For concrete in particular, what we did is we took a look at the global warming potential, or GWP, benchmarks for concrete ready mix products that are already available in the US. So we set our 2022 benchmark in the US based upon the median environmental product declarations of values that were put out by the National Ready Mix Concrete Association and the NRMCA, as well as the Global Cement and Concrete Association, GCCA. Those are roadmaps that are put out and seemed reasonable by the actual concrete manufacturers themselves. If you go to the next slide, you can see that we broke them out by various concrete strengths. That said, we also sort of listed that average there, so you can track where the overall flow down towards zero, where each of those concrete strengths are supposed to get to by 2050. So using that 2022 benchmark, we applied reasonable expectations for concrete technology improvements over the next few decades to achieve decarbonization. These included efficiencies in concrete production, savings in cement and binders, savings in clinker production, carbon capture, utilization, and storage, and then finally recarbonation. Producers should find that these targets were set on a pretty reasonable timeline, given that the methods were consolidated from existing and industry inputted roadmaps. And why it's so important to have a roadmap like this is that it adds transparency to the producers of the products. And by setting these guidelines clearly, the federal government lays out what the expectations are going to be coming down the pike. Anish, if you can go to the next slide. So to jump into steel, we applied a very similar methodology that we did to concrete. So our analysis averaged the assumed percentage reductions from two major industry roadmaps, the IEA NZE and the MPP NZS pathways, as decade over decade scenarios to project reasonably aggressive paths towards net zero procurement of steel in 2050. If you go to the next slide. Steel products have different paths to zero based upon their ratios of primary and secondary steel. That said, the methods responsible for decreasing embodied carbon from steel across the federal government come from the same primary levers. And those were increasing secondary steel content, electrical grid decarbonization, material efficiency improvements, technological improvements in the actual production itself, and then carbon capture, utilization, and storage. Now, we obviously threw a lot at you there, but the report, it has a much greater level of detail and in-depth breakdown as to the explanations and the assumptions that went into these. Anish, if you can go to the next slide. So steel and concrete make up an enormous share of the construction industry's carbon, but there are a lot of other building products that contribute to the emissions. So in particular, a federal buy-clean policy should establish emission standards, and therefore we gave projections based upon thermal insulation, acoustic insulation, concrete masonry, paint, carpet, acoustic ceiling, and aluminum, as stated here. And we took a look at each of those individual materials and we drew a pathway for each of those industries to get to zero by mid-century. And we did this using internal analysis that was built on the back of GWP benchmarks from the Carbon Leadership Forum's Materials Baselines report. The analysis recommends that emissions targets are going to be tightened over time, right? And using this roadmap, we believe that the emissions from federal buildings can realistically hit zero carbon or perhaps carbon positive by 2050. Anish, if you can go to the next slide. This is our projection and where we believe that we're going to be able to get the federal government to by 2050. So if the federal government is able to set and then stick by those buy clean targets outlined in our report, we believe that it's possible to reach that zero in carbon emissions. And what we did is that we used various projections from high impact materials, and then we charted this pathway in summation of all the different materials in relation to the business as usual case that's shown here. Now, obviously, this seems like a huge task, but what Anish and I will do here briefly and then more in depth in the report is that we can take you behind some of those calculations and show you how we got there to get a little bit more clarity. You can go to the next slide too. So our first step was essentially moving beyond that first round of materials that we spoke to. So what we did is we took a look at a swath of building materials that are used in new construction and interior fit outs for federal construction. And then we evaluated the global warming potential in each of the largest building types in the GSA portfolio. If you go to the next slide, I'll detail that briefly before tossing it over to Anish to continue. But we've been talking a lot about the individual materials of a project. And if we zoom out and we take a look at this whole project view, these are the types of projects and what elements from each we actually included. So the federal government does a lot of interior fit outs. They reuse a lot of existing construction in addition to new construction. So it was really important that we quantified the impacts of fit outs beyond the actual core and the shell modifications that you might make. Now, that said, no modeling and no analysis is completely holistic. So there were elements of our scope that we were not able to include, and those were mechanical, electrical, and plumbing emissions or carbon emissions from embodied carbon, fixtures, furnishings, and equipment, and then envelope replacements. And the reason for that is that those are gaps in how embodied carbon is being evaluated. And right now we hope to be able to move into looking into that in the future. So at this point, I'm going to hand it back off to Anish, and he'll talk a little bit more about what went into the calculations.
Thanks, Connor. So for the next few slides, we'll dig a little bit more deeply into our analysis and explain some of our key assumptions. Because in this space, there's a lot of information being thrown out, and we want to be very clear about what is in our analysis, what's included, and what our assumptions are. So our key data sets that we are using for our quantification of the embodied carbon impact of the federal portfolio are these three key items. So the first one is we need to develop what the prototypical material usage is. So how much of what material is the federal government using for its building projects each year? Our key data set for this is using some prototypical building project profiles from RS Means. RS Means is a common cost estimation tool used by contractors, and they have a robust data set of prototypical buildings, which we used to kind of develop what the material quantities for typical building projects and interior fit outs look like. The second piece is the emissions benchmarks for those key material categories. I think Connor spoke to this in a good amount of detail, but just to clarify that once you have a quantity of materials, in order to get to an emissions estimate, you need some benchmarks for what the average emissions of those products are. So our key data set here is the Carbon Leadership Forum's 2021 EPD benchmark survey. And CLF has a number of great resources and are constantly working on updating data sets like this. And I believe that they're actually updating their benchmarking report at the moment. So just wanted to point out that these are using the 2021 values, with the exception of concrete, where we did have more recent data from NRMCA. And so the concrete numbers are updated from this report. And then finally, how do we scale up from the typical building project to the scale of the federal portfolio? And here we're using information from the Federal Real Property Profile, or FRPP, which is a data set that logs how much square foot of different building types and program types the federal government is leasing, owning over year on year. And so it sort of tracks what the footprint of the portfolio is and what type of projects are really being pursued by the federal government. So the first two, the prototypical material usage and the global warming potential benchmarks, are put together, and we've been able to create some prototypical cradle-to-gate embodied carbon benchmarks for building projects. So the charts that you're seeing on your screen right now, the left one is a cradle-to-gate embodied carbon estimate per square meter of ground up new construction by different structural types. So from left to right, we're looking at a typical new construction commercial concrete building, a commercial steel building, a commercial light framed lumber building, and then on the right are more of an industrial or utility program type. So a concrete construction for a utility building, and then a steel construction for utility building. So these are whole project embodied carbon benchmarks. We want to clarify that these are cradle to gate, so they're not what a true whole building life cycle assessment is intended to capture. But these are reasonable benchmarks for what the median embodied carbon impact of projects are. On the right, you're looking at a detail of interiors alone. So for a commercial project and a utility project, what the breakdown of interior materials are. So these are some early benchmarks for the building industry to use. There's a lot of effort underway by researchers to create benchmarks for whole projects. And we encourage portfolio owners and policymakers to reference these benchmarks or test them out as you're trying to estimate what the cradle-to-gate climate impact of your project pipeline is. And so while the next step in this analysis is specific to the federal government, the analysis before this and preceding this and the benchmarks can be used by all folks in the building sector. So looking specifically at the federal government and that FRPP data set that I spoke to, taking those prototypical projects and scaling up to the federal government was quite a challenge. But there was good data in the FRPP data set, and this pie chart summarizes what our assumption is for the annual project mix type is by floor area. So you can see in dark brown that interior modernization or retrofits to existing buildings account for 50% for the commercial side, and then for utility that adds another 9%. So in total, 59% of the floor area that the federal government is working on, from our estimates, is a modernization project, with the remainder being new construction. So we want to be clear that we're not just looking at ground up new construction. This is a holistic profile of the typical projects that the federal government is pursuing year on year. And all of that adds up to this pie chart, which is across all of those project types, what the cradle to gate carbon impact is. And so you can see concrete, steel, no surprises there. They're major emitters. You can see insulation is high up there. a brief explanation for that is just insulation. There are a number of different specific products in the insulation category. And so the median insulation product may not be that great, but there is a very simple choice that contractors have to make a choice to a low carbon insulation product. And so theoretically, the 7% that's for insulation could be dramatically reduced with just a change of product choice. And beyond that, we're looking at additional concrete products, concrete masonry, acoustic steeling, paint, and carpet. I know there were some questions or a question or two in the chat. We'll come back to those unless Connor is able to answer them directly, but I'm sure folks have more detailed questions about this information, so we'll get there. So while we were focused on Buy Clean and really providing some key recommendations to government stakeholders for next steps on Buy Clean, we also wanted to be comprehensive in our recommendations for how we think the federal government should address embodied carbon. The first key piece of that is the importance of investing in deeply decarbonized materials. So while near-term actions on Buy Clean are bringing the floor up for the industry, so we're creating benchmarks to eliminate the worst performing products from an emission standpoint, we need to be seeding the next generation of advanced materials so that the federal government can realistically, move along that trend line that Connor showed earlier to get to zero by 2050. And so right now, we believe that it's important for public demonstration projects, competitive bidding protocols, potentially minimum quotas for advanced, deeply decarbonized products, and other strategies to be used to seed investment in those technologies. And so for Buy Clean, that's looking at low carbon ready mix concrete beyond what's the median in the industry today. Investing in disruptive low or zero carbon cement products that are the future for the concrete sector. Doing demonstration projects to pilot performance of those products, and setting some targets to procure low or zero carbon steel as those products start to come online. But we believe that this is a place where federal funding could be beneficially allocated to catalyze markets for deeply decarbonized products. Beyond Buy Clean and beyond the material categories that are covered under Buy Clean, the investment in deeply decarbonized products could also focus on bio-based products like insulation and finished materials, mass timber, and CLT, or prefabricated low carbon building products that come to site pre-assembled. So we're looking for investment in sort of the next phase of low carbon products and materials. Another strategy is incentivizing carbon storing buildings. So one piece that's missing from the Buy Clean framework is a mechanism to incentivize alternate material selection or just efficiency or material reduction by designers at the project level. And we think this is a critical piece of the puzzle, which is why we modeled whole project LCA performance standards as our second pathway to 2050. And so in whole project LCA, just as Buy Clean focuses on setting emissions targets for specific products, whole project LCA sets them for the project. And you could visualize the relative impact of major material categories as we did in the bar charts for prototypical buildings that we shared earlier. And really, the payoff for this is that over time, this would accelerate uptake of emerging bio-based materials, carbon storing materials, and enable a carbon positive future for federal buildings. And this is why we're really excited about whole project LCA performance standards and see this as the next phase of embodied carbon policy. And finally, not leave without mentioning the importance of saving existing buildings, repurposing existing buildings. One of the best ways to address embodied carbon is to minimize the amount of materials that you're using in the first place. So we did model a portfolio planning approach that the federal government could pursue, which prioritizes renovation of existing buildings to accommodate new growth versus new construction. In some ways, we believe that the federal government is already headed in that direction due to changes in the workplace after the pandemic. So from our estimates, the true growth projection for the federal portfolio may look closer to what we've estimated as the climate smart portfolio planning framework rather than the business as usual case. So altogether, this is how we envision an embodied carbon policy framework rolling out for the federal government. You can see, business as usual, that typical growth pattern based on what was seen in the FRPP data set. The lighter blue line showing what can be achieved just by starting today with a mode shift in the type of projects that the federal government is building. And from there, charting the buy clean pathway to zero, and more exciting, the whole project LCA performance standards and the real impact of that and how that would really accelerate the path to zero and get you to zero potentially a decade earlier than simply focusing on major material sectors. But we don't believe those are mutually exclusive. We think it should be that both happen together. It's challenging to fully eliminate concrete or steel from the building sector. So buy clean is an important piece of the puzzle, but we think a holistic framework is an important complement to that. And again, this embodied carbon policy framework could apply beyond the federal government to local and state portfolios and to the private sector. And the two main pieces are material focused initiatives, getting some benchmarking going, setting achievable global warming potential standards, and creating a target reduction trajectory for those key material categories, but complementing that with pilots for innovative technologies so that we can performance test some of those, and also looking at benchmarking at the project level and creating LCA performance standards. And this is cost effective to implement today. A previous report by some colleagues of ours at RMI showed that many of the emissions reduction strategies in key material categories can be implemented at no cost premium. So you can see up to a 33% reduction in concrete emissions at low or no cost. And so you can achieve major emissions reductions today in a cost-effective manner, while also incentivizing the next generation of technologies. We have more resources on embodied carbon on our website. We have a deep dive into concrete solutions for those who are interested in that material category specifically. That's what we have. So thanks for your time. If there's any questions, we can put them in. You can put them in the chat. I know Chris has some questions too. If there are any clarifications that need to be made.
Anish, I've been going through and answering some of the questions live as they come in, but are you still able to see the Q&A? There was a question from Toby that I might recommend.
Oh, great. Yeah, I can take that one. So Toby's question is there any kind of carbon target pathway being proposed that encompasses whole project carbon including embodied and forecasted operational carbon? That's a really good question, and it's one that Usry is investigating, in fact. So looking at how holistic, embodied, and operational impact analysis would look like. The challenge with that is drawing the boundary on the lifespan of the building life. And so there hasn't been a standard decision made on what that lifespan should look like, for how many years you would be accounting for operational energy and carbon. That's a great question, though.
Yeah, and the one from Harsh that popped up was in relation. They had asked a question if there was good research on biogenic carbon storage benefits, and I can't reference a particular study right now. I know that we included that sort of as our encompassed deeply decarbonized materials that we were speaking to, but in terms of a specific study, Anish, I don't know if you have one, but I don't have any off the top of mine.
I don't have any off the top of my head either. I think there's a lot of great research being done at the project level. So design teams that are working on mass timber buildings, conducting whole building life cycle assessment to investigate what the true benefit of biogenic carbon storage is. The caveat that we've seen come up a lot is if you're taking credit for biogenic carbon storage, you need to have some certainty of the end of life of those materials, because if it just ends up somewhere in decaying, the carbon cycle means that it'll just go back to the atmosphere. So those are some nuances of biogenic storage that are being investigated by researchers. I haven't seen one that's very comprehensive that looks at a broad set of products, but mass timber and CLT are probably the furthest along. It's a good question. Are there any other questions or others that were responded to that would be worth clarifying?
I believe that the other ones are mentioned. I just want to flag once again, we've mentioned it a couple of times. People have been asking questions about the cost of this, and there was some work that was done by Rebecca Esau, Matt Young-Klaus, Victor, other people on our team who had a report that very explicitly addresses that, and it lists a number of different really low to no cost moves that you can make into procuring lower embodied carbon materials for existing and future projects. So that's literally called reducing embodied carbon in buildings, and Chris linked that solutions guide in the chat as well.
Lila had a question on circular economy. That's a really good question. In the pathways that we've identified, both by Clean and the whole project LCA pathway, there would be benefits of the circular economy, which is reusing materials at the end of life and new products, would be potentially captured as part of the upfront emissions. So if you're a steel producer and you're using recycled steel, that's captured in your EPD. And so some of it is inherent to the way that emissions accounting works. So those aspects of circular economy are included. Again, encouraging building reuse is an important element of circular economy thinking as well. But there are certainly elements of circular economy that are sort of left out of this specific quantification. We have published an insight brief to recommend some policy approaches to increase circular economy in the building sector. I think Chris might be able to drop that one into the chat as well.
He just did, so that's in there.
And we had a question about sharing slides and recording. Yes, I believe that will be posted. The recording will be posted online. I think those are all our questions in the queue. Feel free to add any more. Chris, did you have any questions from our kind of clarifications and pre-populated questions that you wanted to pepper us with?
Chris had asked if there were any specific examples for agencies that were purchasing deeply decarbonized materials. I could speak to it a little bit, but
yeah, go ahead.
So the GSA is already looking at this. So they have moved ahead with some of their buy clean procurement strategies, and they are starting to set thresholds for priority materials. I think it's concrete and asphalt, if I'm not mistaken, right? Yeah. And by doing so, they're sort of GSA for a lot of different things is at the forefront of pushing for buy clean right now in the federal government. So they've started stipulating that you have materials that are 80% or better than the rest of the market. And we are hoping that a number of other federal agencies are going to start looking at that as well.
Yeah, and I think that given the funding and the Inflation Reduction Act, there is a lot of work underway, both at the White House, GSA, and EPA to develop the mechanism for rolling that funding out and making sure it has an impact. Right, we have a couple more questions coming in. Which tool do you use to calculate embodied carbon? So there are many different tools that can be used for whole building life cycle assessment. So I want to clarify that if you're a design team working on a project and quantifying embodied carbon, you're using software such as One-Click LCA, Athena Impact Estimator, Tally, which is a plugin for Revit. However, that's not what we used in our calculations. What we've done is we've taken material-specific benchmarks and material quantities from a prototypical building project that's on RS Means, and done a sort of a simplified cradle-to-gate estimation for project embodied carbon. So that's a good question about tools. And our approach, since we're looking at it at the portfolio scale, is instead of doing this analysis for one specific building, really trying to achieve a level of applicability or scalability across the buildings industry. So we're using prototypical buildings. Someone is asking, can you expand on explanations on the benchmarking and piloting in your slide? Sure. I think you might be speaking about this slide, piloting. So the approaches on this slide are looking at beyond buy clean. So buy clean, again, is setting reporting requirements for steel, concrete, glass, asphalt products. The first step, to your point about benchmarking, is that the folks doing procurement need to set a benchmark for what is feasible while maintaining some competition in the products that they're getting submitted to them. And so benchmarks are available for, or benchmarking can be more feasible for product categories where there's a lot of EPDs today. So for example, the concrete industry has more participation than some other industries in producing EPDs. So getting benchmarks set for those is much easier, which is why GSA, for example, has already piloted benchmarking for concrete. But when we get to the point about piloting, so if we take concrete as an example, the GSA standards for concrete as part of buy clean are intended to create a floor and still enable competition in the market. But the pilots we're recommending here would be creating a way to procure more advanced low carbon concrete products. So the best in class products, the next generation of low carbon concrete mixes. There's a whole list of technologies that are available or emerging in the market now to achieve low carbon concrete. And so the pilots would be performance testing of those in things like sidewalk pours outside of buildings, or certain small pavilion buildings, small impact buildings. And then competitive bidding protocols, that's creating a bidding protocol where you're just asking folks to submit bids and report their emissions. So for concrete, just reporting what the emissions impact of your materials are, and then evaluating them against one another and offering the bid to the lowest carbon product. So without setting a benchmark, you can even create just a competitive practice so that the lowest carbon product is the one that folks are fighting to achieve. Does that answer your question? Data variation and gaps. That's a good question. I think that at the portfolio scale, we're looking to develop an estimate or an order of magnitude estimate of this impact. So we acknowledge that some gaps are there, and we tried to explicitly state that in our report and presentation, that things that are excluded, that are gaps, should be noted, because that's an important assumption. Connor, anything else to add there?
Yeah, as I was going to say, in terms of gaps for data in collecting what GWP is for existing materials, there's a couple of different ways that Carbon Leadership Forum and other groups who evaluate what the baseline environment is for different products do. It's, if you don't have enough EPDs for a particular product, you look at as similar of a product that you do have data for and attach that on with some stipulations that it shouldn't be taken at face value, but it's really good for modeling and estimating. So there's always going to be gaps in data. Modeling is never perfect, but we did try to state pretty explicitly in our report where we thought that our gaps came from. So
awesome. Any other questions? I think we could do one or two more if anyone has any clarifications. I know it was a lot of information at once.
I'd also encourage folks to, after they read and maybe digest the report a little bit, our email information is stamped across the header of the report. So if there is clarification, we would love to help you figure that out.
Again, yeah, I think one question that we have gotten recently is questions about the IRA funding and what we see as the opportunity there, and what the timeline is for rollout of that funding. The impact of that funding can be really major if it's spent well, and that's where we believe that this discussion of buy clean and then advanced or deeply decarbonized materials is really important, because there are certain practices by building product manufacturers that are just best practices that many of them are already doing and achieving at low or no cost, as we've mentioned. So we think that the best impact of that funding would be to set a stretch benchmark for buy clean, or a way to incentivize performance beyond what the best practices in the industry are, rather than paying for something that the industry might and is already doing at cost. So that's a major goal for us in how the IRA funding is allocated. In terms of a timeline, people ask that all the time. I think from what we've heard, the ball is in EPA's court, and so they are working on a framework with agency partners to develop the right way to allocate that funding. And we should also mention that that funding, we're focused on buildings in this report and analysis, but there's a transfer funding and a lot of work going on for transportation infrastructure. Federal Highways has a sustainable pavements group that is working on actually a similar roadmap, I believe, for transportation projects, and working with state departments of transportation on low carbon materials. So, two sectors working on this at once and sort of trying to stay aligned. Any last questions, Chris or Connor? Any last things we should share with folks?
No, I don't believe so.
Great. Well, thanks everyone for joining. If you haven't already, please read the report, get into the weeds. And if there's any questions you have when you're in there, as Connor mentioned, our emails are open, and feel free to directly reach out to us. And we're also open to collaborations if you're folks who work on building portfolios and construction. Always looking for partners to advance this work. And this is, again, a broader set of resources that RMI has published recently on these topics. All right, well, thanks everyone. And hope you enjoy the rest of your day.
Yeah,
Get
thanks.
out and vote.